Have you ever wondered what our solar system looked like in the past? Were the planets the way they are today, or did they look completely different? In this video, we will travel back to learn what the planets looked like 3.8 billion years ago. Before we begin, why 3.8 billion years? We selected this date and no other because it was around this time that the solar system was ending a period known as the Late Heavy Bombardment Period. This period took place between 4.1 and 3.8 billion years ago. During that time, relatively brief within the cosmic scale, there were a large number of asteroid impacts with the planets and objects of the interior of the solar system. Gaseous planets. We usually like to start with the planets closest to the solar system, but in this case, we will make an exception since the gas giants have not changed much in their history. Why? The reason is that they do not have a solid surface. Because of this, during the late intense bombardment period, Jupiter, Saturn, Uranus, and Neptune had many asteroid impacts, but these sank into their clouds, and therefore their appearance remained the same. Some astronomers believe that Jupiter and Saturn changed color slightly since the minerals that the asteroids deposited in the gas giants could change the coloration of their clouds, but very slightly. This was deduced from the impact of comet Shoemaker-Levy 9, which fell on Jupiter in 1993. This comet deposited vast amounts of material on the surface of Jupiter, which created a powerful dark vortex on the planet, which slightly changed the composition of its clouds. But beyond that, it is most likely that the gaseous planets look the same as they look today. Not so their moons, since probably in the remote past, the gas giants perhaps did not have as many moons as now, such is the case of Neptune and its largest moon, Triton. Today we know that the gravity of the icy giant captured this moon and that at first it was not part of this planet. Mercury. Making clear what the gas giants looked like, let's move on to the rocky planets, which were completely different. Starting with Mercury 3.8 billion years ago, this planet looked like a fire pit after the late heavy bombardment period ended. Analyses by the MESSENGER probe have shown that the surface of Mercury, like that of the Moon, has numerous meteorite impacts ranging from a few meters to thousands of kilometers. Some of the craters are relatively recent, a few million years old, and characterized by a central peak. Older craters have had extreme erosion, possibly due to significant temperature changes ranging from 623 Kelvin, 350 degrees Celsius, daily to 103 Kelvin, minus 170 degrees Celsius at night. Like the Moon, Mercury appears to have undergone a period of intense bombardment by large meteorites about 4 billion years ago. During this period of cratering, Mercury received impacts throughout its surface, facilitated by the vital absence of an atmosphere that could disintegrate or slow down many of these rocks. During this time, Mercury was volcanically active, forming basins or depressions with lava from the interior of the planet and producing smooth plains similar to the seas or maria of the Moon. Proof of this is the discovery by the MESSENGER probe of possible volcanoes. The plains of Mercury have two distinct ages. The young plains are less cratered and were probably formed when lava flows buried the previous terrain. A characteristic feature of the surface of this planet is the numerous compression folds that crisscross the plains. It is thought that as the planet's interior cooled, it contracted and the surface began to deform. These folds can be seen above craters and plains, indicating that they are much more recent. The Mercurian surface is significantly flexed by the tidal force exerted by the Sun. The tidal forces on Mercury are 17% stronger than those exerted by the Moon on Earth. Something remarkable in the geology of Mercury is the Caloris Basin, an impact crater that constitutes one of the enormous meteoric depressions in the entire solar system. This geological formation has an approximate diameter of 1,550 kilometers. Before the flyby of the MESSENGER probe, it was believed that the size was 1,300 kilometers. It also contains a form of unknown origin not previously seen in any other celestial body, and also consists of approximately 100 narrow cracks and smooth ground known as the Spider. In the center of this is a crater. It is unknown if this crater is related to its formation or not. All this shows us that Mercury had a very violent past, and it is likely that it did not look anything like what it is now, because with so many meteorite and comet impacts, it was a sea of fire much warmer than it is today. Venus, the hottest planet of all, where there are sulfuric acid rains and temperatures exceeding 480 degrees Celsius, is not always the hell it is today. In fact, all analyses show that most likely, billions of years ago, Venus was quite similar to Earth. After the meteorite bombardment period, several comets fell on rocky planets, including Venus. As you know, comets are vast bodies of ice and the largest reservoirs of water in the solar system. When these comets fell on the planets billions of years ago, the ice melted and turned into water. If the planet had enough gravity and an atmosphere, that water could stay and become oceans, lakes, and rivers. It is believed that in the past, in the history of the solar system, the climate and atmosphere of Venus were more temperate, with temperatures reaching 50 degrees Celsius, something much friendlier if we consider that currently temperatures on Venus exceed 480 degrees Celsius. With those temperatures, it is possible that Venus had oceans full of water like Earth, in addition to possibly having all the conditions to have living beings. For at least 300 million years, Venus could retain all the water deposited by comets and had a much richer atmosphere in carbon dioxide. Still, eventually something happened and caused it to gradually accumulate more and more carbon dioxide, heating the entire atmosphere and causing the water to evaporate until it disappeared completely. Over the years, the planet was warming and trapping greenhouse gases, which caused it to stop being a friendly and quiet planet with water and become the hottest planet of all. Venus has a greenhouse effect that does not allow heat to dissipate and retains gases, heating its surface and preventing any life from forming. The Earth. Without a doubt, the most different planet was ours. Earth has not always been our beautiful and peaceful blue home with oceans and forests full of abundant life forms. 3.8 billion years ago, after the late bombardment period, the Earth looked very different. At that time, our planet was at the beginning of the Archaic period. In this period, there was an evolution of the Earth's crust, so there had to be plate tectonics, plate movement, and an internal terrestrial structure similar to the one we know today. However, it was differentiated by excess heat. It is estimated that there was more seismic activity due to the incredible speed with which the lithosphere is produced, so there would also be expected to be more significant activity in the dorsals. The dorsals are submarine elevations that occur due to the movement of tectonic plates. At this time, there was more significant activity in the subduction zones, and a greater number of plates and smaller ones that caused constant earthquakes throughout the planet. Active volcanoes everywhere and a higher concentration of greenhouse gases in the air, especially carbon dioxide. The atmosphere lacked free oxygen. Temperatures appear close to current levels even at 500 million years of Earth's formation, with liquid water present as evidenced by some highly deformed gneisses produced by the metamorphism of sedimentary protoliths. Astronomers believe the sun was about one-third as bright as today, which may have contributed to the decline in global temperatures. It is thought that at this time, there was the most significant volume of greenhouse gases at any time in Earth's history. During this time arise stromatolites. Stromatolites are important fossils resulting from the activity of groups of cells and colonies forming sedimentary rocks that began to form 3.7 billion years ago, with a maximum abundance of 1.25 billion years ago. Geologists have discovered that these organisms consumed carbon dioxide and transform it into oxygen. In other words, these were responsible for filling our planet with the oxygen we breathe. As you can see, billions of years ago, the Earth still did not have the conditions to host living beings like those of today. In fact, it is likely that all of the living beings that exist today, very few could survive the conditions that our planet had at that time. Mars. Finally, we have Mars. Scientists think that Mars looked a lot like Earth in the past because after the late bombardment period, like Venus and Earth, Mars also received the impact of several comets that filled it with water. Because of this, Mars had a much denser atmosphere than it currently has. In addition to having much more pleasant temperatures, oceans, and rivers full of water, all the conditions to house living beings. Exploration probes have now found traces of what appear to be water currents that once existed on the red planet, and have also discovered that there are small deposits of water mixed with sand or clay under the Martian surface. Undoubtedly, Mars was a much more hospitable place for life in the past, and that is why many scientists think that life may have originated here and then migrated to Earth via asteroids. This is what we know as the panspermia theory, which we talked about much more in depth in the video we made about whether there may be dinosaurs on the moon. Mars was for many years the most hospitable planet for life, actually could have better conditions for life than Earth, but unfortunately its core is tiny. Because of this, it cooled very quickly, which caused the loss of its magnetic field. Without a magnetic field and with feeble gravity, there was nothing to protect the atmosphere from solar radiation. Eventually, the solar wind was gradually tearing off the atmosphere of Mars, which decreased the atmospheric pressure, evaporating the water and causing it to disappear from the planet until it was completely dry. As you can see throughout history, the planets have undergone significant changes that led them to be what they are today. Still, thanks to this, a planet succeeded and managed to obtain the necessary conditions to house living beings. If we have learned anything by studying the past, it is to understand what the future will be like. Today, we know that the Earth and the rest of the planets continue to evolve, and that our planet will not be forever the hospitable home it is today. So we must take care of it and protect it until we find a new home on some other planet in the universe. Would you like us to make a video about what planets will be like in the future? Leave us your valuable comment to find out.